Elon Musk's relentless drive, his unwavering belief in the possibility of reusable rockets, kept the team focused and motivated. They worked tirelessly, day and night, fueled by a shared determination to solve the complex puzzle of controlled rocket landings. Sometimes the boosters would touch down, only to wobble precariously and then tip over. Other times, they exploded in a ball of fire upon impact. And on several occasions the rockets missed the landing mark by just a few meters, a frustratingly close margin. As these failures mounted, critics were quick to mock them, questioning their approach and their chances of success. But the SpaceX team remained undeterred, pressing on with unwavering resolve, meticulously analyzing the data from every mistake to identify areas for improvement. Elon Musk's journey began in the heart of South Africa, not with grand pronouncements but as a quiet, curious boy, often lost in the captivating worlds of science fiction novels. He devoured stories of distant galaxies, futuristic technologies, and the boundless possibilities of space exploration. He spent countless nights gazing at the stars, dreaming of space and what wonders it held. While other kids played outside, engaging in typical childhood games, Elon imagined humanity exploring the stars, especially Mars, the red planet that captured his imagination like no other. For him, Mars wasn't just a red dot in the night sky, it was far more significant. It was a potential second home, a crucial backup plan for humanity's survival and future prosperity. He firmly believed that our long-term future as a species depended on becoming a multi-planetary civilization, expanding beyond the confines of Earth. After achieving considerable financial success with PayPal, a venture that revolutionized online payments, he could have easily retired and enjoyed a life of leisure. But instead, he embarked on an audacious mission to build rockets and transform space travel. The established aerospace industry met his ambitions with skepticism and laughter, doubting that an outsider could possibly succeed in such a complex and challenging field. But Elon was unyielding in his determination. If he couldn't buy a rocket to pursue his vision, he would simply build one himself, defying all expectations. And so, in 2002, he founded SpaceX, a company driven by a singular purpose. Its bold mission was to revolutionize space technology, drastically reduce the cost of space travel, and ultimately, make life multiplanetary a reality within our lifetime. He assembled a small, passionate team of engineers and visionaries, and they began their work from scratch in a humble California warehouse. Their initial, seemingly impossible goal was simple: build a rocket, but not just any rocket, one that could reach space far more cheaply and efficiently than anything that had come before. The world, or at least those who noticed, largely saw a dreamer, perhaps even a madman, but Elon saw something far more tangible, a detailed blueprint for humanity's future among the stars. This marked the very beginning of an absolutely incredible journey, one filled with challenges, setbacks, and ultimately, groundbreaking achievements. The odds were overwhelmingly against him. But for Elon Musk, this was merely the starting point, a challenge to be overcome. The childhood dream of Mars was rapidly transforming from a far-fetched science fiction fantasy into a tangible, achievable reality. To truly appreciate SpaceX's groundbreaking achievement, we need to delve into the core of their innovation. And to do that, you need to understand what a rocket booster fundamentally does. It's not just about adding power, it's about overcoming immense forces. Imagine trying to throw a ball not just across a field, but all the way into space, a truly Herculean task. Realistically, your arm simply isn't strong enough to impart the necessary velocity. The Earth's gravity is relentless. A rocket booster serves as that incredibly powerful arm for a spaceship, providing the initial surge of energy needed to break free. It's essentially the bottom section of the rocket, densely packed with powerful engines and a vast reservoir of fuel. This is where the magic happens. It's responsible for generating the massive, sustained thrust required to overcome Earth's relentless gravitational pull and propel the rocket skyward. The booster's primary mission is to lift the rocket with its precious cargo through the densest, most resistant layers of the atmosphere. Then, once its fuel reserves are depleted, it detaches from the main rocket body, separating once its job is done. Historically, for many decades, these incredibly complex and powerful boosters were designed for a single use, only to be used once and then discarded. They would either burn up during re-entry into the atmosphere or simply crash into the ocean, becoming space junk. This is analogous to buying a brand new state-of-the-art airplane for every single flight and then throwing it away after just one trip. A staggering waste of resources. This inherent wastefulness made space travel an incredibly expensive endeavor, a luxury that few could afford, effectively limiting access to space to only the wealthiest governments and the largest, most well-funded corporations. Elon Musk recognized this inherent inefficiency as the single biggest obstacle standing in the way of making space truly accessible to all. He understood that if he could successfully solve the problem of booster reusability, he could fundamentally change the economics and accessibility of space travel. The crucial element was reusability, the ability to recover and reuse these powerful boosters again and again, flight after flight. And that's precisely what SpaceX boldly set out to achieve, a seemingly impossible feat at the time. The future of affordable and sustainable space travel, and perhaps even humanity's expansion into the cosmos, depended on it. Musk's radical idea: land rocket boosters back on Earth, refuel and reuse them. If successful, this would slash launch costs and open space to more than just governments, but landing a 15-story metal tube, falling at hypersonic speeds, was a huge challenge. SpaceX designed the Falcon 9 with landing in mind, adding grid fins for steering and landing legs for touchdown. The booster uses thrusters to flip, then reignites its engines to slow down and guide itself to a precise landing. Experts called it impossible, like balancing a pencil on your finger in a hurricane. But SpaceX pushed forward, inventing new ways to control and land rockets. The landing sequence became a ballet of fire and precision. If they could master this, space would never be the same. The world watched, waiting to see if they could pull it off. The path to groundbreaking innovation is rarely smooth. Success didn't come easy for SpaceX. It was a long and arduous journey filled with unexpected challenges and setbacks. SpaceX's early attempts at landing their Falcon 9 rockets were anything but graceful. These initial landings often ended in fiery crashes, dramatic explosions that underscored the immense difficulty of controlled rocket descent. These spectacular failures were what they jokingly, and perhaps a little morbidly, called rapid unscheduled disassemblies, or RUDs for short. But within SpaceX, each failure wasn't viewed as a disaster, but as a crucial lesson, an opportunity to learn and improve. They meticulously analyzed the data from each RUD. In the beginning, they started with a simple goal: to see if the booster could even survive the intense heat and pressure of re-entry. So they tried landing in the ocean. In many cases, the structural integrity of the rockets was compromised during descent. Most boosters broke apart before they even reached the water's surface. And for the ones that made it, they often hit the water too hard, resulting in catastrophic damage upon impact. Despite the setbacks, each attempt, each RUD, brought them incrementally closer to achieving their ambitious goal of reusable rockets. Unlike traditional aerospace companies, which often prioritize avoiding failure at all costs, SpaceX embraced failure as an inevitable and valuable part of the innovation process. Next, they upped the ante, aiming for a precision landing on a floating drone ship, affectionately named "Just Read the Instructions." These landings were nothing short of dramatic. Sometimes the boosters would touch down, only to wobble precariously and then tip over. Other times, they exploded in a ball of fire upon impact. And on several occasions the rockets missed the landing mark by just a few meters, a frustratingly close margin. As these failures mounted, critics were quick to mock them, questioning their approach and their chances of success. But the SpaceX team remained undeterred, pressing on with unwavering resolve, meticulously analyzing the data from every mistake to identify areas for improvement. The pressure within the company was immense. With each failed landing, money was rapidly running out, putting the company's future in jeopardy. And each crash was incredibly costly, both in terms of hardware and the resources required for salvage operations. The problems they faced were multifaceted, ranging from seemingly minor issues like running out of hydraulic fluid during the landing sequence, to more critical malfunctions, such as the landing legs failing to lock properly, leading to the booster toppling over upon touchdown. But Elon Musk's relentless drive, his unwavering belief in the possibility of reusable rockets, kept the team focused and motivated. They worked tirelessly, day and night, fueled by a shared determination to solve the complex puzzle of controlled rocket landings. Every RUD, every fiery crash, brought them one step closer to a breakthrough, providing invaluable data and insights that informed their design improvements. They refused to give up, driven by the conviction that their success would not only revolutionize spaceflight but also pave the way for a future where space travel is more accessible and affordable. December 21st, 2015, SpaceX prepared for a historic Falcon 9 launch. The real test: could the booster return and land upright on solid ground? As the world watched, the booster separated, flipped, and began its descent. The grid fins steered it, engines fired, and the landing legs deployed. In a cloud of smoke, the Falcon 9 touched down gently at Cape Canaveral. Cheers erupted at SpaceX. Years of work had paid off. Elon Musk was jubilant. Critics were silenced. They had landed an orbital-class booster, something once thought impossible. Soon after, they landed a booster on a drone ship at sea, an even tougher feat. What was once a spectacle became routine. Falcon 9 and Falcon Heavy boosters now land regularly. Twin boosters landing in sync became an iconic sight. SpaceX had made reusability real. The dream was now a standard part of space launches. The world had witnessed a new era in spaceflight. The impossible was now possible. Startups, universities, and even small countries can afford to launch satellites. Starlink, SpaceX's global internet project, became possible only because of cheap, reusable launches. Remote villages, ships, and planes now access high-speed internet, thanks to Falcon 9. The industry is more competitive and innovative than ever. The Falcon 9 is the workhorse of modern space, launching everything from government satellites to private astronaut missions. Most importantly, these technologies are paving the way for Starship, SpaceX's next-generation, fully reusable rocket. Starship aims to take humans to Mars, building on lessons from Falcon 9. Routine landings are just the beginning. The real goal is a multi-planetary future. The highway to the heavens is open to all. Reusable rockets aren't just for astronauts, they impact all of us. Cheaper launches mean more satellites, better internet, and new opportunities worldwide. Starlink is closing the digital divide, bringing education and commerce to remote areas. More satellites mean better data for climate agriculture and disaster response. SpaceX's innovation inspires a new generation to pursue science and engineering. It proves that bold ideas and perseverance can solve big problems. The ultimate vision, making humanity multiplanetary, ensuring our survival. Colonizing Mars may seem distant, but reusable rockets are the first step. They turn science fiction into achievable engineering.